Hello everyone, I am Shafika and I am from Catchment and Waterways Drainage Operations in PUB. I'll be sharing on PUB's current drainage inspection methods and providing more insights on the kind of solution that we are seeking. In Singapore, rainwater is collected through 8,000 kilometers of drains, canals and rivers. As part of the maintenance regime in PUB, manual inspection of public drains are conducted typically once every 5 years to check for defects and to ensure drainage network is structurally safe and functional. PUB has explored the use of drones to inspect closed drains and provide visual images of their conditions. The primary intent of using drones is to improve productivity by reducing the time and manpower required and enhance safety by eliminating the need for confined space entry. However, there are limitations to the drones currently in use. The current drone solution is unable to inspect smaller drains lesser than 2 meters, which forms a significant portion of the drainage inventory. Bigger size of drone also face difficulty in maneuvering around any services present within the drains. The drone is waterphobic and hence man entry to manually follow the drone when flying it in a partially submerged drain is required. This is so that the drone can be picked up before it hits the water surfaces. Additional limitations of the current practice would include the following. Currently, manual intervention is needed to identify defects from inspections. To reduce the manual intervention in routine inspections, drain defects and anomalies need to be detected automatically using AI. Another challenge would be updating of drainage network and asset records. The existing drain network alignment and asset details in geospatial database need to be verified periodically by our officers. Hence, there's a need to map out the drain alignment and dimensions into geospatial database while performing inspection. Hence, we hope to achieve the following in the solution we are seeking. To be able to inspect the drainage network which consists drains of various types and dimensions and in different environmental conditions. For example, partially or submerged from time to time due to tidal or reservoir level influence, turbid waters, presence of animals such as bats, snakes, obstruction by services, etc. To be able to identify the drain defects and anomalies automatically without manual post-processing. And lastly, to be able to map out the drain alignment dimensions of open and closed drain in both GPS-enabled and deep night environment to an accuracy of 0.1 meter for horizontal and vertically placed burn and upload this information into a geospatial database. I would also like to highlight some pertinent challenges and considerations for noting when designing the solution. They include the following. Firstly, solution should be able to fit through drain access opening, for example, minimum 0.7 by 0.85 meter for typical roadside drain. Solution should be able to enter drain at access points that are spaced at varying intervals depending on size of the drain. Secondly, solution should be able to inspect drain that could be under various conditions. For example, partially or fully submerged condition due to tidal influence, turbid waters, presence of animals such as bats and snakes, or obstruction by services. Third, solution shall not also involve personnel to follow the autonomous robot or drone during inspection to retrieve it in the event of failure. This would be a strain on manpower resources and is disadvantageous. Fourth, solutions shall be able to automatically and accurately detect and identify defects, ideally providing measurements to determine the extent of the defect. Fifth, solutions should be able to automatically generate inspection reports with location data, images, and video timings to support subsequent investigation and rectification works. The inspection and data processing methods, for example, data transfer and report generation, should adopt innovative methods that require minimal manual interventions in order to achieve smarter operations. And lastly, the solution shall be affordable for large-scale implementation. For reference, the drainage network in Singapore is about 8,000 kilometers. At the end of the day, we look forward to an autonomous inspection solution that are cost-effective, able to identify defects without manual interventions, and with the ability to map our drain alignment and dimension. If the pilot is successful and is picked up by PUB for further assessment, the solution would be provided to PUB through a service model where the equipment is owned, operated, and maintained by the company. I have now come to the end of my presentation. Thank you for your attention and I look forward to working with you.